So I'm here to show you that this, what Marek has actually been talking about, is not just our dreams, it's a reality. It's something that we have already made, and we are working on that. But you can still, as Marek said, you can still go to vlayer XYZ and just go through the documentation and start playing with it. So this is a homepage for the developer, so this is where you should go. So let's start with bookvlayer.xyz. It shows you that the documentation is meant to be like the source of truth and like the main help doc for the developers. So it goes with the warm intro, how to use it, what features do we have. It gives you also an overview how to get started. It gives you an overview of the features that Mark has mentioned, so time travel, teleport, email, web, JSON and regex, all of that. There's also something advanced about what a prover is, what verifier is, so on and so forth. Let's start with getting started. So let's start with the installation and how to install basically vlayer. As you can see, we have like a couple of prerequisites, but most of you should probably know that you should always have like a Git or Foundry. Like basically what we are doing, we are enhancing Solidity, but we are also enhancing Foundry project. So if you have already if you have already created a Foundry project, like the workflow would be very familiar to you. But how to install vlayer? You just go to our book. You just install it as if you would install, let's say, Rust or Foundry. So let's go and here. Is it big enough? Hope it is. Yeah. So I'm just trying to install vlayer app. So I'm downloading the installer. It installs vlayer app, and then just after that, I can run vlayer app to install like our main product, the vlayer. It's usually a bit faster, but the internet here is not the best, but we are trying our best. Yeah. So once we have it. Once we have installed that, so as you can see, it just took me like 2 steps only. It was very quick. Then I can create a very first project as if you would go with Forge init or something like that. So in this case, you run vlayer init, and let's say it is a simple example. So what we do, and again, like let's give us a moment about the internet, but what do we do here? So in here, we are trying to create a Foundry project. We are initializing a Foundry project. We are creating a vlayer directory. Basically, we are creating 2 vlayer directories so that you can differentiate between what is a Foundry and what is vlayer, what actually vlayer adds to a Foundry project. So we create basically 2 directories. Let me go into it. Simple example. Let's say like this. So at the top level, what you can see is that is basically a Foundry project. So you can see Foundry.toml. You can see the remappings that you are already familiar with. And we've got our source directory, we've got our test directory. We also add to you the vlayer directory, more on that later on. So what do we give you also is src. And let's see what is actually in the src. So in the source file, Foundry usually gives you the counter.sol, which is their very first template, the very first example they are giving to you. We are adding to that our vlayer directory, which in this case gives us the simple prover and the simple verifier. I will show you how it works. Yeah. I hope you see it. So this is very familiar, similar to what Marek showed you just before, but this is basically the live code you will be able to compile, to run, to test it. And as you can see, we've got 2 types of the contracts. This is the prover, so this is the thing that is being computed, that is being executed from within the zero-knowledge virtual machine, from the coprocessor. It's being executed off-chain. So basically, it's not executed on-chain. The contract is deployable, is deployed to on-chain, is deployed to mainnet, let's say, but you don't execute any function of that, because for some reasons, for some examples, let's say with the email or with the web proof example, it's not viable to actually run these transactions, to run these functions on-chain, because let's say you will quickly run out of gas, let's say because of the cold data size. So what do we have here? In here, we just have a simple constructor. So when you deploy the contract, you set the two immutable parameters. You set the ERC20 token address. So we'll be basically proving our balance of an ERC20 token in this example. So in this case, in the constructor, we are just pointing and pinning the ERC20 token that we want to prove. Let's say it's a USDC token, and then we are pointing and pinning the block number that we are actually interested in. So let's say this is basically an airdrop. So if you had a specific number of tokens at a specific block number, then you will be given an NFT. So this is the constructor, and then there is the other function. It's called balance. On Marek's examples, what Marek was showing, it was always the main function. But it's not the case. Like, the prover can have as many functions as it can. Basically, what is very important, I will show in the verifier, that you strictly have to connect which function is being proven, and I will show you how to do that. But basically, the function can be called whatever you want. So this is the balance, just a simple balance. So it has just one argument, and it returns basically the address and the balance alongside with the proof that I will show you later on. So if you go to the function, in the first step, what we do, we are just setting the block number that we are expecting to have the proof about. Then we are just fetching, like using normal call that you would call from the Solidity on chain. So we are just taking the token, we are taking the balance of an owner, just call a function, bam, we've got the result, we've got the owner balance. What we do in the next step, we just return the proof. This is basically how the proving works. It is very important, as Marek told, and I will show you later on, that it's very important to pass this proof as the first example, to make it easier for everybody, basically for the developers, so that you don't have to work with the ABIs. Then there is the owner, so we just copy the argument, we pass to the output, to the return, and then the balance that we have just proven. Yeah, so this is it. Let's go to verifier. The verifier is a bit longer, but it's as simple as the prover was. So in here, the simple verifier, as you can see, it has some example NFT, it has the address of the prover. So what is very important is the connection between the prover and the address, the prover and the verifier, so that we don't accept just proofs from any prover. This is the prover we trust, this is the prover we accept proofs from, and none of the others. So in the constructor, we just pinpoint to the prover that we accept, that we know code of, that we know how it proves, what it proves. Then and then when somebody calls, this is basically the function that you call on-chain, that we send transaction with the proof, then we can basically check that the verification has been done. The verification is done on the proof from the right prover. And basically, this function, what it has 3 arguments that are basically the output what the prover gave us. So the prover gave us the proof, so we can see in the first parameter. Then the address, it was returned. I will show you later, or maybe even now. All right. So you can see that the very first example here, it is the proof as the input. Then that was the output. The proof was the output of the prover. So the second parameter is the address, and the third is the balance, exactly as here in the prover. So what we do then in the function, there is one very important thing that we know that like the proof has actually been verified is we are using the only verified modifier, which before you even go into the body of the function, it checks the proof, like the first parameter to the function, it checks the proof, how it does it. It knows how to does it, how to do it. It takes care of all of the ZK proving and so on. But what is very important, you have to point which verifier did you expect, which prover did you expect to run. So that's why we have to pinpoint to the prover, and also the function that we expected it to run. So if the prover had like 10 functions or 20 functions, then we would have to basically we do have to actually pinpoint to the function that we executed, that we expect to be executed. Then the proof has been verified. Yep. You can see this is the balance and this is the balance selector. So this is the syntax of Solidity. Yep. We are just importing. We know from Solidity we know the selector of the simple prover because we just imported it from here. Like there is a simple prover, we import it, so we have all the functions selectors, so we know it. Sorry. And yeah, and the selector of it. Yep. Right. So, and then what we do, when we go into the function body, we already know that the proof has been verified, so we don't have to care anything about what proof has in its call data. We don't care about it. We just now can proceed with our business logic. So we proceed with the business logic, checking whether the claimee has claimed the token. If already claimed, then we just revert. And if the balance is over like 10 million, we mint an NFT token for the guy. Yep. So this is as simple as it. What we also provide, what I told you that I will show you, we also provide some tests that you can basically run and see that everything goes through all the points that it's not that I'm just showing you the Solidity code and then make you like please merge it together, but we are also having a script that merges it together and like shows you that whenever you change anything, that we'll be able to actually work with it. So there is also, and it shows you how to work with it. So there's also the proof.ts in the other vlayer directory. What it basically does, it creates the token that we want to prove the balance of. We are minting the token for John in here. We are minting the token for John. We are also creating the NFT token that we will be minting later on. And then in the next step, we are deploying vlayer contracts. So a pair of them, basically, the prover and the verifier, with the constructor arguments passed to both of them. So you can see that the prover args, so the first contract args are passed here, and the verifier args are passed here. Also, as you may remember that the verifier had the prover as its first argument, so we do it like under the hood. So we are basically that's why we are deploying the two contracts together, so that we do we connect the contracts for you. Like you don't have to do it. Then in this code, what we do, we are just connecting to vlayer client, and then we are just running as simple as that. We are using the vlayer proof function, like, and what it returns, it just returns us the proof. So as you can see, we are taking the prover address, we are taking the prover ABI, which is like TypeScript specific, how it calls each function, and then we are pointing at which function we would like to call and passing the arguments to it. So as I told you, that the proving function was the balance, and it takes an argument of an address. So here you go. Like as I told you that we created some balance for John of the token. So let's check if John has this balance. So this is it. And then what we do, we just basically passing the arguments back to the verifier and call the verifier claim whale function, which is basically the function that verifies the proof. Yep. So we can go, and this is as simple as run banner. But here it works. But what you can see in here, this is the very same example because I wanted to have it prepared for the case. But what you can see, what we are returning from the as the proof result, we are returning the proof structure, which is quite big, but it doesn't really matter because we don't have to understand what it is. But it gives us all of the arguments that we will be checking. This is the proof, the first argument, and there's the second and third argument returned from the prover. So you can see this is the John's address, and this is his balance, like 10 million. 10 million. Yep. So this is it. This is the simplest example we do have, but we also have something more complex, and this is about the emails. Email prover. Yeah, this is it. So there's the other example. You already know the structure, how it looks, how it works. So, but this gives us two new capabilities, two new superpowers. So as Marek showed you, we are going to check. Here, this is just the main function, but here in the prover, we are passing an unverified email, which is basically an email that you're getting, like the MIME encoded email that you're getting from your email server. And why do we call it unverified? Because up until now, these are just text, basically these are just bytes. We don't know anything about the email until we verify it. The verification, what it does, it checks the DKIM records, it checks the signatures, it basically checks whether everything is correct from within the email in a cryptographic manner, and then we take some of it, return it to the user so that it knows. Basically, these are the unverified email. These are just bytes, and the verified email, what it returns, is a structure that has a subject, that has a from field, that has a body, and this is what we do in this magic trick. So this is the unverified email. We verify it. It returns us the email, and on that we can do many tricks. So what we can do, we can go and check whether the email subject is basically whether it fits the example, the regex, but also what we are taking is welcome to vlayer, and in here what you can see is quite similar. It's 40 characters, and as you may think, it's just an address of the user. So hello, so the subject should be hello to vlayer, and then your address, let's say. So, and what it does, it not only confirms that the regex matches, but also it returns you the address that you wanted to match. So you can take that. Then we have to ensure that the captures match, that the whole pattern matches. We go to the we do check whether it's a valid email address, and we check that the from, so the sender, that it's from vlayer domain. So these are the two checks we are checking here, and we do, in case it doesn't check, we revert. As simple as that. Then after all those checks, this is quite complex. In here in Solidity code is quite easy, but underneath, we are doing many magic to make it happen for you, so that you don't have to know anything of the details about how regex work, how DKIM records work, or anything like that. And as very similar to as what you do in the simple example, we are just returning the proof and the address from the capture from the subject. So when we go to the verifier.sol, here is the connect function, the verify function, which takes the argument as the proof, then the address, the wallet address. Again, the only verified modifier, which takes the prover, because again we have to know to ensure that this is the prover we accept, this is the prover we want, the prover we know, and the selector of the function, in this case the main function. And again, we could do whatever we wanted in here, but the logic in here is that require wallet, so the address that sent, that's what was in the subject, is the message sender, and then put whatever logic you want in here. So this is it. We also, what do we also provide you? We provide you with the vlayer test tool, which is, as you know, Forge test. It runs the test. So we're providing you with the very same tool. So instead of Forge test, you would write vlayer test, and it runs all the tests. It can accept both vlayer tests and Solidity tests, and Forge tests and Foundry tests. So how do the tests differ? What superpowers do we give to the tests? This one, tsol here. So what I showed you is it was that you could run all you wanted from Solidity, but you can also test what you wrote also in Solidity. We are giving two more superpowers, and basically this is very similar if you're familiar with, if you know Foundry, how Foundry tests work. They are operating on something what is called cheat codes. So this is also in such a manner we are doing it in here. So we do provide with the call prover. So we know that the next call you are doing in the next line basically will be executed in the prover environment. So we will generate a proof for that. And it will be executed in very similar manner as it would be executed like basically in real life on production. So we call the prover, we then run the verified email, we get it to verify. What it gives us, the output of the function of the verified email. Give you the arguments, subject from is the dinner ready. This is it. Thank you.
So I think I understand the superpower behind the emails. Can you walk me through the email data flow a little bit? Because, for example, most of the transactions that would require proofs might be financial. For me, in the use case that he pitched also, it's a custodian thing. Fund managers usually need this kind of proof for submissions, taxes, and other things as well, which is quite cool. But how can you walk me through the flow of storage? Even if are you storing it in the logs in the backend? Even if the proof goes up, can I recover the complete emails and the details, or I just get the headers? Can you walk me through the security part a little bit?
One thing that is very important to understand is that whatever you give to the verifying function, to the proving function, this email that you're passing here, it is the private input. So basically, if you try to execute that, like the verifier function on chain, that this part of the data is not leaked. What only thing that is basically executed on chain and is known on chain is what the prover returns to you. So basically, what you have in the verifier in the prover function as the input is always private. So this is one thing. The other thing is, as you said, if we were to execute this on our servers, then we do have access to your emails. Yes, this is true. But one thing that is quite good about it, that you can run prover on your machine. So it doesn't really matter. Like for some use cases, when you want the proof to be quite fast, then you can you can find your sweet spot between the privacy and the speed. So if you care about the privacy, the security as much, you can run it on your laptop. It will take probably a couple of times longer, but you're completely secure. You don't leak your data. And if you do care about the time, then you just pass the data to us. Sure. But the thing is that we never store it. Like we just compute, we do the computation, we do the proving, and we never store it. Like all the data you are passing to us, we never store it.
Yeah, I understand, but I just wanted to know because the use cases that come, they ask for such things, NDAs and other things.
You can do it locally.
Sure. Thank you for answering.
Any other questions? Thank you, Dan.